God, what just happened?
Did I mention spelling tomorrow?
We have spelling tomorrow.
If you were asked to graph this, x equals 5, it'd be a relatively easy thing to do, so it would just look like this. Here's 5, there's a point there. That's all x can equal. It's 5. There's nothing else there. With inequalities, though, if I asked you for numbers that were greater than 5, okay, you could give me an infinite amount of answers, 6, 7, 8, 9, 10, whatever. So that's why when you graph inequalities, you end up with that solid line telling somebody that you can have any answer that starts at 5 and goes forever this way. And you must be careful, we've done this since whatever grade. Since there's no equal sign there, it would start at 5, but it can't equal 5. So hence the reason why you put an open circle there. Okay, it starts at 5 but can't equal 5. 5 is not a solution, but 5.001 is. So this open circle says it starts at 5, but 5 isn't the answer. Whereas if you had x is greater than or equal to 5, because 5 can be the answer, you color it in and might make a nice dark circle there. Okay. This graph represents all the possible answers that you could give. If I asked you what the domain of that would be, you would say x would have to be anything greater than or equal to 5. That's the domain, because that's what it is. That's all the answers there. You don't usually give domains.
Wait, what's the little thing on the
5 there. Now,
screen?
here is what you must be careful with, especially with negatives. When you talk about inequalities, some fundamental rules we usually go by. There are small exceptions to them, but here's what number one has to happen. The variable needs to be on the left. We don't write inequalities like this usually. You don't usually say 5 is less than x. Okay? You usually say x is greater than 5. Okay? So number one, we want the letter on the left side. Number two, we want the variable to be positive. And that's pretty commonplace. We really don't ever want to see a negative x. You with me, Sam? Really? And the fix of that is very easy. If you have a negative x equals a greater than or equal to negative 2, how do I fix that? Well, you're allowed to change this to positive as long as you change this to its opposite, as long as you change this to its opposite. Everything needs to be changed to its opposite when you do that. To change the variable to its opposite, sign has to go opposite, answer has to go opposite. That's the reason I told you not to do some of those problems on that, because you probably didn't necessarily do that. Here, let's look at an example.
Like, do we have to do that?
Yes. If you end up with an answer that looks like this, negative 8 is less than or equal to negative x. Breaking every rule of the inequality, we need to fix it so that it is right. So what all has to happen here? Well, the letter has to go to the other side, and it needs to be changed from its negative to a positive. So here is the look on this here. I can move this negative x to this side and that negative 8 to that side, but the same thing is true. If I flip-flop these things, you kind of think about this as being on some sort of an axis, the sign has to change as well. Okay? If you rotate this around, the x comes over here, the 8. In other words, if the alligator was eating the negative x to begin with, it has to be still eating the negative x if you flip it to the other side. But now you follow the rule that says, okay, I don't want this to be negative, so it becomes positive, this becomes its opposite, and this becomes its opposite. So negative 8 is less than or equal to negative x is the exact same thing as x being less than or equal to 8. I suppose. And then when you graph it, what does that look like? Here at 8, it is a close circle,
Wait, why did you?
Wait, why is it?
huh?
Why?
Left.
Isn't it supposed to
I don't know why it's going to the left. Why is it going to the left?
be Mr.
Because x is less than 8. 8, 7, 6, 5, 4, 3, 2. Notice how this little gizmo gadget right here, Charlie,
Yes.
is the same as this little gizmo gadget here. Almost they're looking exactly the same. Arrow pointing this way, going this way. Taylor Pavia has a question for one and all.
Yeah, I do. Why? So the little, what do you call that little thing in the middle?
Inequality.
The inequality, okay. Why is the inequality, you like switched it in the middle, but then you switched it back at the bottom?
Because I did two different things. The first step, I flip-flopped the x and the 8, which means I need to flip-flop the sign. Then the second step, I change this to its opposite, I change this to its opposite, I change that to its opposite.
Oh, so really, it's all one step, but you showed us in two different steps.
Now, it's two steps.
But could you
I wouldn't
just
do it all as
Taylor,
one
you
big
do
thing, because I think you would just get confused.
switch, but you would just have to switch them and take away the negatives, right?
Just do it that way.
Right, but that's not, you can't say that's always gonna be the case.
Because
Because,
sometimes you can
because
add
Taylor,
negatives.
if this was the problem, -7 is less than or equal to normal x.
Yeah.
I only have to do one of those things. I only have to switch this from this side to this side. This is already positive, so I don't have to make it its opposite. So that would be the
Would it its
result there.
opposite be negative?
Huh? Yes, its opposite would be negative. Is this positive? Rule has this has to be positive. If it already was positive, I don't have to do anything.
So it'd be
Taylor, the other one
-7
is
going.
So this would be, yes, Charlie, -7, closed circle, going this way.
Oh, because they all have to be positive, alright, I got it.
Ava?
What if like the x canceled out 1, 2, 2
I don't know what that means.
on both sides? Like it was like 2 minus x is greater than 4.
That's a good question, because these get a little more complicated. 2 minus x is what?
Greater than 4 minus x.
4 minus x.
Comes smart.
Listen, because this probably comes up on the worksheet somewhere, doesn't it? Is that why you said here?
So
Here is the deal, kids. Take a look, see, listen, because you are in 8th grade, and this should start to make a little sense to you. Alright, I want to move my x's to this side, so I'm going to add x. Now notice when I just change their signs, the sign changes here. Signs never change. This will not change to a greater than sign if I add or subtract things over. If I add this x over here and this x over here, it doesn't change signs. It's only when I, at the end, have a negative, because then what I'm actually doing is multiplying or dividing by a negative. I'm just adding x, I'm adding x, and what happens here? Negative x plus x is 0 x's. I subtract my 2, I subtract my 2 over there. 0x is greater than 2. Anybody tell me what the deal is with that? Because this is what Ava was going for. Anybody going once, going twice, going 3
You
times?
just do T.
How do I get rid of that 0 in front of the x?
minus.
No, not the
Cancel
minus.
it out.
I divide by 0. Oops, sorry.
And then 0.
Ladies and gentlemen, at the 8th grade level, you should understand what happens when you divide by 0.
You're gonna
I
say
mean, look at commandment number 1.
That's what I'm fine with. Undetermined.
Undefined.
classified.
No, so it's
Yeah.
solution.
No solution.
So that's the answer to that problem.
Which problem?
It cannot be done. And if Ava was up here, she would tell you this. That makes sense because let's just pick a number for x, 5. 2 minus 5 is -3. 4 minus 5 is there ever going to be a number in there that you could put in for x that will at any time give you in this a number bigger on the left side than on the right side? No. +4. If I put +4 in there, 4 minus x is -2. 4 minus +4 is 0. Negative 2 is not bigger than 0. This is an unsolvable, there is no answer to this because there's no number of x that you could put in there where this left side will ever end up being greater than that side. Ever. And that's what happened here, why we got 0x is greater than 2. 0 times no number will ever give you something greater than 2. Ever. Hence the reason it was
Isn't it just like 2 divided by 0, still 2 though?
No, 2 divided by 0 is undefined, you cannot divide by 0, ever.
Isn't that what we learned when we were little though?
No, 0 divided by 2 is 0.
Oh.
You can divide 0 as many parts as you want, still get 0.
Wait,
If I have 0 apples, children, if I have 0 apples and I divide that 28 ways to give you all a piece of it, how many apples are you going to get? 0. Okay?
what if you got 20?
If I have 28 apples and try to divide it 0 ways, that makes no sense to nobody.
Because then you just have the one
So
x.
it equals 1.
You would just have the
Oh,
20
yeah.
x. No, you wouldn't.
You like, that's just 5.
And here is, if you want the explanation to that again, 15 divided by 3 is 5. When you do this, these two numbers multiplied have to give you the top number. Okay? If you put a 0 on the bottom, then you ask yourself, what number would you multiply 0 by to get 15? You're going to spend a long time trying to think about that because it's impossible.
What would like a smart person try to do if they didn't know that rule, they were trying to get it?
Would say you can't do it and stop because there are things that can't be done in your life. Kendall,
And
I have two questions.
let's start with the first one.
Do they divide by 0 in high school?
No,
Oh.
that's a commandment. You can't break that one no matter how high you go.
Is it a commandment or?
No, I didn't make the poster,
He printed it out from Carolina Mathematics.
Okay, why can't
but that's a good question.
It says thou shalt not divide by 0.
It's the first one, it's the most important.
Kevin, quickly, because I got one more thing to talk about.
And do we have to simplify those equations?
What about 17?
That's where I'm at right now. Just touch.
That one.
or what is 17?
And 19.
Work with me here, kids.
Guys gave me.
David,
Yeah, I already did it. I think 1 is like.
I already did the 5 pages.
Why does it say where we are? Again, you are in 8th grade. If you can add or subtract, multiply, and divide by any little numbers, this should not be that difficult. You just follow the same rules. You've done this before. You solve it, first of all, just like an equation.
I'm saying it.
In other words, this, children. Okay. If this had just an equal sign in here, what would you do? The first thing you do is you simplify both sides of the equation. What can you do to make them simpler? Well, this one you can't do anything with because it's just 28 minus 6. But this one over here, what are you going to have to do? You do the distributive property first. Negative 8 minus 6n plus 42, correct? Negative 6 times n, negative 6 times negative 7, positive 42. Then you can still combine some stuff over here. What happens when you put a negative 8 with a 42?
You get a positive something.
35.
35.
Sorry.
Step number 1 is done. I just simplified all I could on each side. Then step number 2 is move all your variables left and all numbers right. And again, you will not change the signs on this because you do this by adding and subtracting. You don't do this by multiplying. So I just simply do this. What did I do? This n's gone. I need to add 6n. I need to add 6n. Now, right here you get 0n, which means
Nothing.
you can't stop
No
right there.
solution.
You can't stop right there because there's one other thing that could happen. Just listen to me. Okay, you need to make sure that you don't get 0 on the other side, because if you have 0n is greater than or equal to 0, that can be done, because 0 times what number is 0?
1.
Any number. If you get 0n,
One.
So it's infinity.
if you get 0n equals 0, it's infinite solutions. Okay, but if you get any other number besides that over here,
We are getting another number.
then there's no solution.
No solution.
Wait, so it was no solution.
Yeah.
Taylor Pavia has figured it out.
But I just told you, Taylor, you can't just stop as soon as you see a 0n and say there's no solution. You need to make sure that there is an actual number on the other side. Because if it was just a 0, it's infinite solution.
But isn't the other side 0 and 2?
No.
So,
Okay.
Taylor.
Wait, no,
We're gonna
How do
do
you
one
grab-
more.
wait, no, wait, I have a quick question, I have a quick question.
You can ask me that. Let's do number 19. I'm gonna actually have you do 19 right now, right where you're sitting.
Okay, I'm done, no solution.
It's infinity.
No solution.
It's infinity times infinity.
I don't know. Nuh-uh.
Taylor,
Do that problem for me.
Oh, you can combine that.
Yeah, Kyle should be in the math.
Give you a second to do that.
But you are.
Not that difficult.
That's what they all
You're a math teacher.
Wait, where does that one?
I'd start with the number first thing I said to do and the other thing. Simplify each side. You're gonna do the distributive property on the left. This side right now is as simplified as it's going to get for right now. You need to figure out what this gets down to be 2 terms. Distributive property and combine. Questions there? Do you have an answer? No, I'll get the answers here in just a minute.
Alright, wait, alright, I'm feeling this. Okay.
We're gonna.
Okay. Done.
I'm not done yet.
See, this is what
I
my
write it
question
down
would
right?
have laid in though. This one, this is where my question would have
Forced community, no talking class, which I don't like to do. I just write it out. If that's what it is. Sometimes math isn't as perfect as.
The front was using the back. Solution.
I think I got it right.
No.
So once you do the distributive property here, you get 32n minus 20, 8 times 4.
I got that.
Oh, there's a 4 out there. Oh,
I didn't even get that.
wow.
Tim, what for?
Then you can combine the two n terms. 32 minus 7 is 25n minus 20.
Then you minus 7 and then minus plus 20.
Now you bring your n terms to the left side, your numbers to the other, so you subtract 7n, that gives you 18n. Add 20 over here, you get negative 18. Negative 38 and a positive 20 is negative 18. Divide by 18. Divide by 18.
Sam.
And less than or equal to negative 1. Graphing at negative 1 equal to
Okay.
less.
I don't even know I did that. Oh, I got the 8. Well, yeah, I definitely got that.